Let's look at 1.6b. So we are solving other types of equations. So this first one is going to blow your mind. It's pretty exciting. Equations that are quadratic in form. Okay, so an equation that is quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. So here is the type of problem that you'll be seeing. So it's going to have x to the 4 minus 10x squared plus 9 equals 0. So the reason it's quadratic in form is because you have something to, so x to the 4th and then x squared and then a number. What we've had before is like x to the 4th, x to the 3rd, x to the 2nd, and x and then a number. But this one just has to the 4th power and to the 2nd power. And it's a trinomial. So what we can do is we can substitute in just a generic u in the place of x squared. So that way we don't have to worry about that x to the 4th because that's it's hard to make sense of it. So we'll substitute in u for x squared, rewrite the equation, and then solve like a quadratic function. Not actually solve, but factor like a quadratic function. And then substitute x squared back in for u and solve for x. So if you see this problem right here, I'm rewriting it so that I don't have that x to the 4 anymore. So it's x squared. So something squared minus 10x squared plus 9 equals 0. So I'm replacing this x squared with u. And I made a mistake. This x squared with a u. So there should not be that squared there. That's a mistake. Sorry. So it should be u squared minus 10u plus 9 equals 0. I got carried away with my squareds. Then that makes more sense to factor. You think about the u like an x, and then you would factor it. So we are going to factor and solve this. And thinking back to Algebra 2, or even pre-cal, this is how you know the most number of zeros that you have, the largest exponent. So if we have to the 4th power, that means we could have up to 4 zeros, which are your x-intercepts. If you get more than that, that means you did something wrong. If you get less than that, that means that one of your zeros is at a maximum or a minimum. Let's say it's like that. So this only has 1, but it has so many turns on it. To the 4th power would actually be something like this. So those would be your solutions or your x-intercepts. This is actually to the 3rd power, but this one's to the 4th power. So let's look at how to solve this. And I made that little mistake there. So mark out that extra squared with the 10u. And we'll rewrite it. U squared minus 10u plus 9 equals 0. So now we can factor it. So what numbers are factors of 9 that add to get negative 10? So after we factor it, now we plug x squared back in. So I'm now going to replace this with x squared. So now this is x squared minus 9. X squared minus 1 equals 0. So I substituted x squared out, put a u in. I factored, then subbed x squared back in for u. So you're subbing in and out until you can factor. So now we can factor these. If we have x squared minus 9, that's the difference of squares. So we'd say x plus 9, x minus 9. Not 9, 3. And then this one would be same thing, minus 1 plus 1, plus 1 minus 1. Then we would solve. So then x equals, we're going to write it as a solution set. So what are the solutions? Negative 3, positive 3. I should have just wrote them down here. 1 and negative 1. You do want to make sure that this is true. So we need to sub it in. Either sub it in or look at your graph and then look at the table of values. So we'll put it in with the x. So x raised to the 4th power minus 10x squared plus 9. So when we do that, if we hit graph, we should be able to see where it crosses all those locations. So negative 3, negative 1, 1, and 3. Or look at the table. So negative 3, 0, negative 1, 0, 1, 0, and 3, 0. So all those solutions check out. Okay, so let's look at the next one. So this is quadratic in form. So we are going to substitute in u for the x squared. So this would be u squared, because u equals x squared. I'm going to write that out to the side so I know what to sub back in, because it will change on one of the next problems. Minus 8u minus 9 equals 0. So then what are the factors of negative 9 that get a sum of negative 8? Negative 9, positive 1. Forgot extra parentheses there. And now sub back in the x squared for the u. And now we can factor. So this is difference of squares. So x minus 3, x plus 3. This one is not a perfect square. It's not, I mean, they're perfect squares, but we have plus 1 instead of minus 1. So we can't do that one. So we can't even factor it. So we'll leave it just like it is. And so we have x equals 3 and negative 3, because remember we set these equal to 0. I'm kind of skipping a step. I feel like y'all are good on those. So that's how we're getting positive 3. And then the other one is negative 3. Then the next one is x squared plus 1 equals 0. So we'd need to solve that. So we'd have to subtract 1 on both sides. And we get x squared equals negative 1. Then take the square root. Do you remember what square root of a negative 1? Do what? It's imaginary. We have to put plus minus I. So we have two solutions there. You have positive I and negative I. Do y'all remember how i's show up as solutions in functions like this? Do y'all know what that's called in the graph? Okay, well, let's look at it. You'll remember as soon as you see it. Well, we really can't see it, can we? So they don't show up as solutions at all, right? Our only solutions are -3, +3. We don't have any solutions at all. I do want to zoom out real quick. See if we can see it. So we only have 2 real solutions and 2 imaginary solutions is what we have. Okay, let's keep on going. So this is in that same quadratic in form. So we'll let u equals x squared. So I want you to work this one out. Hopefully that gave you enough time to work it out. So look at mine, check your answer. Okay, so we have 7, -7, 2, and -2, and then hopefully you checked it with your calculator. Okay, let's look at the next one. Okay, this is different. So see, why is it different? You would have to distribute. You would have to do x plus 6 squared. But the thing is, see how these are the exact same?
Oh my gosh. We have to simplify.
No, we can actually make it easier. We can say that u equals x plus 6. So instead of multiplying this, distributing this, combining like terms, and then factoring, we can make it a little bit easier by doing it this way. So now we have a u squared plus 8u plus 15 equals 0. And that makes it a whole lot easier. So what would our factors be?
5 and 3.
5 and 3. So plus 5, plus 3. Okay, before we solve, though, we've got to substitute this back in. So then we would have x plus 6 plus 5. And then x plus 6 plus 3.
So x plus 11.
Right, so x plus 11, x plus 9. So what is our solution set? -9 and -11. Okay, so see how much simpler that made it? Instead of having to do this, combine like terms, and then factor, it made it so much simpler.
Do we like have to do it that way? Like not so have to.
No. It's just solving it using that quadratic formula or form, the quadratic in form. Let's look at the next one. So really the only way you can do it like that is when these two are the same. Whatever squared plus a coefficient of that. So see how these are the same? We have the x squared plus x. Which when this is multiplied, it'd be x to the 4th. Then you'd have the x squared. You'd have an x. So what's going to make this a lot easier is whenever you substitute in the u. So it'll be u squared minus 22u plus 40 equals 0. So now the factors, negative 20 and negative 2.
Mrs. Ozzy, where'd you get 22u?
Right here.
Where'd the u come from?
Instead of putting in this x squared minus x, I put in a u. Because I'm saying that u is x squared minus x.
Yeah.
I'm doing the substitution. All right, so I factored. Now I need to sub this back in. And now I have x squared minus x minus 20. And then x squared minus x minus 2. And so what are the factors in negative 20 that add to get negative 1?
Negative 5.
Negative 5, right? And positive 4. And then multiply to get negative 2, but add to get negative 1. Negative 2 and positive 1. Now we'll solve each one of those. So x will equal positive 5, negative 4, positive 2, negative 1.
Easy peasy.
Yeah. Not too bad. All right, the last part, or the last equations we're going to solve is dealing with absolute value. The absolute value of x describes the distance of x from 0 on a number line. To solve an absolute value equation, we rewrite the absolute value equation without the absolute value bars. And we set it equal to the absolute value of u equals c is equivalent to u equals c or u equals negative c. So you're going to create this absolute value from that absolute value equation, write down 2 equations, solve both of those. You must check. Using substitution. Or you can also use the table. There will be answers that are extraneous. They are not true. All right, so we have some examples to work through. So we will write 2x minus 1 equals 5 or 2x minus 1 equals negative 5 from the absolute value equation. Solve them out. Use substitution or use the calculator to put those in. But remember how to get the absolute value on the calculator?
No.
Math, num for number, absolute value, number 1. And then it pops up those absolute value bars. So we'll put in 2x minus 1. But it says equals 5. So how can we put it into y equals? Yeah. And then look at your table. Make sure that 3 is a 0 and negative 2 is a 0.
Correct.
They're both correct. So x equals 3, negative 2.
Is this video just for Lily?
And Ramsey. Okay. All right, so we need to solve this. In order to solve it, we need to get that absolute value all by itself. No, plus 15 first, right? It's okay. And then what? There we go. You didn't even let him say it. Okay. And then we would set them equal 1 equals 3, and then it equals -3. Okay, so solve both of those. All right, so then make sure to check them. Negative divided by negatives would be a positive. So we have -1/2 and +1. Bye. And I'm going to change my table start, or maybe change the table to be half so I can check the half one.
How'd you do that?
Second window.
Second.
And it doesn't matter where you start it. So then we'll check -1/2. It works. What about +1? It works. Okay, so then we can say -1/2 and 1.
Oh my gosh. I don't believe it.
All right, let's look at this next one. We need to get the absolute value by itself. Okay, so before we go any further, y'all look at this one. So I solved it. And what do you notice about that? Can an absolute value ever equal a negative? No. It's not going to work.
We can stop right there.
We really could. There's no solution here. What I did do, though, is I worked it out, and I found those -7 and -3, and then I went and checked it, and then neither one of them worked.
Alright, so anytime we get a negative,
Yeah. If it says the absolute value equals a negative, it can't happen. It's a no solution. So you see how this was positive? This one was equal 0, but when we solved it, we still got a positive answer here. So we know that there was a solution there. All right, let's look at the last one. So x² plus 3x minus 9 equals 9. X² plus 3x minus 9 equals -9. Oh, y'all can't see that. So then we would solve it. We really need to get that 0 over there. So it'll be like this. So x² plus 3x minus 18 equals 0. Then we can factor this. I'd really rather you not be on your computer yet. So it'd be +6 and -3. So then our solution would be -6, +3, but I'm not done with the other one. I need to add 9 to both sides. That would be 0, so this would just equal 0 because they both cancel. So then we'd factor. What could we factor out of those? X. So it'd just be x plus 3 equals 0. So for this, what would x equal? And then what would this x equal?
-3.
Yeah. So we have 0 and -3. So then you just want to check and make sure that that is correct on the table. All right. Your assignment is on Pearson.